Taiwan Semiconductor Manufacturing Company, TSM, remains a dominant force in semiconductor manufacturing but must navigate complex global risks while continuing to innovate and expand in response to rising demand from almighty AI. After an outline of TSM as a company, notable technological innovations as of late will be highlighted, along with related business developments targeting expansion, followed by a discussion of issues related to broader trade tensions and the knock-on effects they could have. For starters, TSM was established in 1987 and focuses on manufacturing for customers rather than designing or marketing products itself. It boasts a wide range of fabrication processes, including CMOS logic, RF, mixed signal, and embedded memory, and provides additional services like advanced packaging and silicon stacking. These semiconductor foundry services are highly specialized for advanced chip manufacturing for industries like high-performance computing, HPC, smartphones, IoT, automotive, and consumer electronics. TSM's scale and technological capabilities, particularly in advanced manufacturing processes, such as 7-nanometer and smaller geometries, make it a key player in the global semiconductor market. It operates 17 fabs worldwide, including in Taiwan, the US, China, Japan, and plans for a new facility in Germany. Major clients include AMD, Intel, NVIDIA, Qualcomm, and Sony. Its expertise is so extensive it extends to cutting-edge technologies like 3D silicon stacking and packaging, enhancing chip design flexibility for its customers. To stay on the cutting edge, TSM introduced its A14 manufacturing technology, scheduled to enter production in 2028. Aimed at advancing AI capabilities, A14 will deliver significant improvements over TSM's N2 process, which enters production later this year. Specifically, A14 promises up to a 15% increase in speed at the same power consumption, or a 30% power reduction at the same speed, along with a 20% boost in logic density. This makes it ideal for AI applications and smartphones, where onboard AI capabilities will be enhanced. A14 will also feature the NanoFlex Pro architecture for better performance, power efficiency, and design flexibility. At a Silicon Valley conference, TSM unveiled a new strategy to improve the energy efficiency of AI chips by using AI-powered software for their design. It aims to boost AI chip efficiency by about 10 times. AI servers, like those from NVIDIA, currently consume up to the equivalent energy usage of 1,000 U.S. homes running continuously. TSM plans to achieve these gains by utilizing multi-chip designs called chiplets, which are smaller chip segments with different technologies packaged together. AI software from companies like Cadence Design Systems and Synopsys has been key to these advances. These tools, developed with TSM, have delivered faster and better solutions than human engineers for certain design tasks, optimizing the use of TSM's technology. This shift is necessary as current chip manufacturing faces limitations, such as data transfer speeds between chips via electrical connections. New approaches, like optical connections between chips, are being explored to address these fundamental physical challenges, particularly for large-scale data centers. The growing TSM and Synopsys collaboration supports advanced AI chip designs and multi-die applications. It consists of certified design flows, IP solutions, and packaging technologies to enhance chip development for TSM's cutting-edge processes, including N2P, A16, and 3D stacked designs. Synopsys' 3D-IC compiler platform and CoWoS packaging technologies enables successful tape-outs for customers. The collaboration also covers AI-optimized photonic flows for TSM's compact universal photonic engine, addressing multi-wavelength and thermal chip design needs. Synopsys IC Validator has been certified for TSM's A16 process, supporting physical verification for advanced chips. Synopsys also provides IP solutions for high-performance standards, such as HBM4 and PCIe 7.0, and automotive IP for TSM's N5A and N3A processes, in addition to taking part in joint development of design flows for TSM's A14 process. Collaboration later extended to advanced simulation and analysis solutions, including AI-assisted workflows for TSM's photonic engine. Certification of ANSYS tools like HFSS IC Pro and RedHawk SC enables final verification checks on designs for AI, communications, and computing applications. Then, TSM's new System on Wafer X technology will integrate large computing chips with memory chips and optical interconnections, delivering thousands of watts of power to support AI-driven workloads. The ramped-up production volume of these technologies is expected in 2027. As part of its strategy to meet growing demand for advanced AI chips, TSM is building factories in Arizona to support this new technology. These plants will contribute to its expanding portfolio, which includes 6 chip factories and additional packaging factories. The construction in Arizona was part of a major U.S. investment push, in line with the company's $100 billion investment in the U.S. over the next few years, bringing its total U.S. investment to $165 billion. TSM's Arizona operations represent the largest foreign direct investment in U.S. history, with the goal of expansion being to reduce the impact of U.S. tariffs on semiconductor imports. It's also expected to create 40,000 construction jobs and tens of thousands of high-tech jobs in Arizona, driving over $200 billion in economic output in the state over the next decade. TSM's U.S. production will also benefit American customers such as Apple, NVIDIA, and AMD by helping them avoid tariffs. The move has been lauded by U.S. officials, including Commerce Secretary Howard Lutnick, as a significant contribution to local manufacturing. Apple CEO Tim Cook and NVIDIA CEO Jensen Huang have both expressed support for the new facility, highlighting its potential to foster American innovation and job creation. TSM's Arizona investment aligns with growing demand for domestic semiconductor production, reinforcing the company's position as the world's largest contract chipmaker and key supplier to tech giants. By 2028, TSM plans to begin producing a 1.4 nanometer chip that's part of the A14 generation. It will follow the 2 nanometer chips set for production in late 2025. Earlier, TSM announced it will phase out its 6-inch wafer manufacturing over the next 2 years, while focusing on consolidating its 8-inch wafer production to boost efficiency. Aligning with its long-term business strategy and was deemed appropriate after a comprehensive evaluation of market conditions. TSM emphasized that it is working closely with customers to ensure a smooth transition and assured that this change would not impact its financial targets. TSM currently operates 1 6-inch wafer fab and 4 8-inch fabs in Taiwan, with advanced node manufacturing taking place in its 12-inch fabs. To enhance AI chip design automation tools and intellectual property for advanced semiconductor nodes, TSM is working with Cadence Design Systems. Together, they focus on AI and HPC applications, supporting TSM's N3, N2, and A16 process technologies. With Cadence's 3D IC solutions aiding TSM's 3D fabric die stacking and advanced packaging technologies. Using Cadence tools like Innovus Implementation System, Quantus Extraction Solution, and Tempus Timing Solution, they are also developing EDA flows for TSM's A14 process. New Cadence IP products now support TSM's N3P process, including HBM4, LPDDR65X memory interfaces, DDR5 MRDIMM, and PCIe 7 IP for AI infrastructure. The partnership also includes AI-driven features in Cadence tools, such as automated design rule violation fixing, for faster design closure on TSM's N2 technology. Additionally, Cadence's 3D IC solutions provide automation for bump connections and physical implementation of multi-chiplet designs, with smart alignment marker insertion for TSM's 3D fabric platform. In the future, progress could also come from TSM opening a chip design center in Munich, Germany. This facility will support European customers in designing high-density, high-performance, and energy-efficient chips for applications such as automotive, industrial, IoT, and potentially AI. It could later assist in meeting Europe's AI chip ambitions by providing advanced manufacturing processes for AI-focused semiconductor development. The Munich Center is part of TSM's broader European expansion, including its involvement in a joint venture with Infineon, NXP, and Robert Bosch to build a €10 billion semiconductor manufacturing plant in Dresden, Germany. This venture, European Semiconductor Manufacturing Co. ESMC, aims to develop chips with smaller manufacturing nodes previously unavailable at European companies like Infineon and NXP. Kevin Zhang, a TSM executive, indicated that the Munich Design Center would support these efforts, potentially advancing Europe's capabilities in AI chips. Over in the Far East, TSM has delayed plant construction in Japan because it's prioritizing its U.S. expansion due to concerns over potential tariffs from the Trump administration. Reflecting how U.S. trade policies are redirecting some of TSM's investment away from allied nations toward the U.S. The delay comes as major tech companies, including Apple and NVIDIA, are increasing U.S. production of AI servers, which were previously manufactured in locations like Taiwan and Mexico. Given TSM's significant market influence with a nearly $1 trillion valuation, the company has become a key investment target for regions like the US, Japan, and Europe. Each of these regions has offered financial support for TSM's expansion plans, but US priorities are now taking precedence. By adjusting its priorities, TSM is responding to the shifting dynamics of global trade and the increasing strategic importance of manufacturing AI-related technology in the United States. Yet its reliance on large customers, geopolitical tensions, and fluctuations in semiconductor demand can impact revenue. TSM is also exposed to risks from the cyclical nature of the semiconductor industry, with potential downturns affecting its margins and earnings. As a result, there's an established risk management system to address operational and geopolitical risks, though managing raw material availability and cyber threats can be an ongoing concern. TSM CEO C.C. Wei acknowledges that U.S. trade tariffs are having some impact on the company, but emphasized that strong demand for AI chips is likely to offset any negative effects. When speaking at TSM's annual shareholders meeting, Wei noted that tariffs primarily affect importers, not exporters like TSM, though they can lead to higher prices, which may reduce demand. However, he assured shareholders that AI demand has consistently outpaced supply and remains robust. Despite the ongoing tariff uncertainty, TSM has not seen any significant changes in customer behavior. Wei also addressed the challenge of foreign exchange volatility, particularly the appreciation of the Taiwan dollar, which has pressured TSM's margins. He noted that a significant portion of TSM's revenue comes from foreign sales, leaving the company vulnerable to fluctuations in currency value. Wei also dismissed reports about TSM potentially building chip factories in the UAE, saying it is not very likely due to a lack of local customers. Though if TSM were to consider building an advanced chip manufacturing facility in the UAE, the project would require approval from the U.S. government, mainly due to national security concerns from U.S. officials. If such a plan ever did materialize, it could mirror TSM's Phoenix, Arizona gigafab. In terms of political risk, Wei responded to concerns about China's military pressure on Taiwan, stating that such matters are for governments to handle, not TSM alone. On a related note, TSM benefits from an exemption to the 100% U.S. tariff on semiconductor imports. This exemption is linked to TSM's plans to expand production in the U.S., a move encouraged by President Trump's tariff policy aimed at boosting domestic manufacturing. On the flip side, the U.S. government can also be a restricting force in some cases, such as when it revoked the company's authorization to freely ship critical equipment to its Nanjing plant in China. The revocation of the Validated End User (VEU) status, effective December 31, 2025, could limit production at the older generation facility. TSM confirmed the notification, stating it is assessing the situation and working with the U.S. government to ensure the Nanjing plant's operations continue smoothly. This move aligns with similar actions taken against China-based facilities of Samsung and SK Hynix. While U.S. officials plan to issue individual licenses to maintain these operations, the shift from blanket approvals to specific licenses introduces uncertainty and potential delays in securing necessary permits. TSM's decision to comply with the new restrictions adds complexity to its Chinese operations and increases regulatory hurdles for importing U.S. chip-making equipment. Adding even more turbulence from politics is Taiwan's decision to reject a proposal from the United States to split semiconductor production evenly between the two nations. Taiwan's top trade negotiator, Vice Premier Cheng Li-chiun, confirmed that Taipei had never agreed to such a deal and would not accept it. The rejection followed comments from U.S. Secretary of Commerce Howard Lutnick, who suggested that the U.S. would pitch a 50-50 production split. Since TSM dominates global semiconductor production as the world's largest contract chip maker, Taiwan has a significant trade surplus with the U.S., mainly due to its chip exports. Despite continued trade talks, TSM continues to produce the majority of its chips in Taiwan, even with the Arizona expansion. Taiwan's relationship with the U.S. remains focused on improving trade conditions, including more preferential treatment on exports, which is where TSM and the larger semiconductor sector could become advantageous leverage. Yet the relationship also sees Taiwan considering a high-tech strategic partnership with the United States, aimed at expanding U.S. production capacity without relocating supply chains. Vice Premier Cheng Li-chiun, leading tariff negotiations with Washington, shared this update after recent talks. The proposal, described as a Taiwan model, would involve industrial investment planning, with government support like export credit guarantees and joint industrial clusters, rather than a shift of production away from Taiwan. The U.S. has asked Taiwan to increase investment and cooperate on supply chains, But Taiwan is committed to maintaining its industrial base in Taiwan while supporting global operations. So again, TSM's $165 billion investment in U.S. chip factories in Arizona will not alter the company's primary production in Taiwan, pointing to Taiwan's firm stance of maintaining cooperation with the U.S., while still ensuring that its semiconductor industry remains rooted in Taiwan while fostering bilateral partnerships. Next, to talk about something more exciting than plain tariffs and politics, trade secret theft was afoot. Taiwanese prosecutors indicted 3 individuals for stealing trade secrets from TSM to aid Tokyo Electron in competing for TSM supplier deals for its 2-nanometer process technology. The primary defendant, a former TSM employee named Chen, allegedly solicited help from former colleagues while working for Tokyo Electron. Prosecutors are recommending a combined 14-year prison sentence for Chen under Taiwan's national security law. TSM, emphasizing its zero-tolerance policy on trade secret violations, vowed to strengthen its internal monitoring systems to protect its competitiveness. In a broader move to safeguard its proprietary technology, TSM has developed a trade secret registration system that catalogs its confidential information. The system, in place since 2013, helps manage and protect intellectual property while fostering innovation. TSM is marketing this system to suppliers and partners in Europe and the US to create a more systematic management of trade secrets. With over 610,000 cases logged, the system integrates AI and cybersecurity measures to monitor and protect valuable technology. Though the recent theft still highlights the ongoing risks and challenges in securing trade secrets. For more on stocks and crypto, follow Ascencore. Thanks for watching and have a nice day.